the mean value of land and buildings per acre from a sample of farm is 1800. All right, I'm gonna go ahead and get my notepad open. This is going to be the empirical rule problem. I love drawing for these questions. I'm gonna get my tablet. So they gave us the mean. That's gonna be in the middle, okay? So hold on, let me draw my picture. You don't have to, but it helps me to see the probability and how the sections are divided. So here we go. So I'm gonna draw a bell curve, and it looks like that. And I have mean marked in the middle. Mean is, in this question, 1800. And standard deviation is 200. So mean is 1800. Standard deviation is 200. So when I make my number line, I add 200 to go to the right side. So 1800 plus 200 is 2000. One standard deviation above. Two standard deviation. It's hard to see. How about I use orange now? 2200. And you just do one more. 2400. Okay, you're just going 1, 2, 3 standard deviation up. Now let's go down. 1600, 1400, and 1200. Just add and subtract the standard deviation to divide up the bell curve. Okay. Okay. Now what do they want? The data set has a bell-shaped distribution. Assume the number of farms in the sample is 73. So under this gray curve, there are 73 farms. But you remember the empirical rule, okay? Empirical rule says in between, hold on, let me draw my lines here, okay? So within one standard deviation from the mean, my picture is not so perfect, but hey, that's okay. It's not so perfect, but what I'm trying to say is, hold on, there are 68% of the farms will be in between 1600 and 2000, okay? And where did I get this number 68 from? The empirical rule, okay? Now, what else? Let me do the orange. So if you stretch out a little bit, within 2 standard deviation from this orange to that orange line. Okay, hold on. Let me bring this down a little bit. So from the orange to the next orange, there are 95% of the data. Okay. Oh, the farms are in between. Now, what about in between the green lines? All right, hold on. From 1200 to 2400. Like almost every farm is gonna be in between, like 99.7% of the farms will be within 3 standard deviation from the mean. Okay, now what do they want? The first one, use the empirical rule to estimate the number of farms whose land and building values per acre are in between 1400 and 2200. Now look at that for me. Look at the numbers they just gave us. So 1400 is the lower bound. So they're asking from this orange, this 1400 to 2200. Didn't we already say, right? We know within 2 standard deviations from the mean, there are how much? 95% of the data. So the first question is, well, hold on, gotta be careful. It's 95% of the total number of farms. So I'm gonna have to write that down. What is 95% of, how many farms they say? 73 farms. So just do 0.95 times 73, okay? All right, let me get my calculator over here and do 0.95 times 73, and that comes out to be 69.35. So I'm going to round that down to 69 farms. So 69 farms are in between those that size. All right, let's look at the next one. If 28 additional farms were sampled, how much, what is this? About how many of these additional farms would you expect to have land and building values in between 14 and 22? So, still, it's gonna be 95% of that number, right? Because they didn't change the bound. So I think I'm just gonna do it this way. I'll just go ahead and do this is the second question. 95% of the additional number of farms, 28 farms. Yeah, I don't know if I'm thinking this is too easy, but all I'm gonna do is do 0.95 times 28. Sometimes, like you're doing math problem and it seems too easy, but then like, am I doing it all right? Let's see if I got this right. So when I did the multiplication, I got 26.6. So I'll go ahead and round that up to approximately 27 farms. So about 95% of these newly added farms will be in between that. So I'll say 27 of those, almost all the farms. Because 95 is big. So it will be unusual to see a farm that is smaller than, or actually below this and lower bound and above that upper bound. So that's how you can do this question. And this one was on question number 14 on 2.4 homework.